Okay, we're doing silicates. So we've just got regular quartz, regular quartz. Note the striations.
Is this how this grew? Because this looks like it has a nice sort of cleavage.
This here is beryl. It's hexagonal.
I don't care if everyone gets 100% on the lab, but make sure you know how to do or figure out what everything is. I will absolutely tell you.
This is orthoclase. It cools quickly. So these, believe it or not, are actually kind of small white crystals.
In a general sense.
So we're looking at the white stuff in here. Orthoclase. This is hornblende.
Historical, we had everything.
Definitely hornblende. Not the white stuff.
Next lab.
This is olivine.
But in order to look at the rocks, you should know what they're made of.
Very green. And sometimes it looks like sand in there. It's really fine. Or it's really coarse grained green stuff. This here is tourmaline, which is the same thing as, thank you, Kimmy, that right there. Okay, same thing, tourmaline. Muscovite, obviously, pretty easy. This is plagioclase, and note the cleavage where the white flashes. And this is actually part of a crystal. That's why you don't see any crystals in it, because it's not even a full crystal. Over here we have yeah. It can look a lot like hornblende, but it's not.
This one is a small one. Yeah.
Take a look at the cleavage and the color, a little greenish.
Oh, you're right, it does.
That's fine.
Yeah.
This is Travis, fresh back from New Zealand.
Yes.
Sorry.
And this is fluorite.
90 degree.
This
Yeah.
and this.
Okay.
So this versus this face.
And this stuff right
Because
here
this is the only thing that
is, I have to look it up. It is
Is that one?
Amazonite or microcline.
This one when I hit.
It's
Oh,
Amazonite microcline or microcline Amazonite.
ornament.
They have the same like striations,
yeah, I see what you're saying.
same color code.
I always look at.
Clearly, any idiot could tell this is biotite. Okay, now Labradorite has this pretty sheen to it.
You still have to say.
So Labradorite. And this right here is kyanite, but I don't have to note for the test. It's the blue streaks in there. Those blue streaks. Right there. It's
I
kyanite.
understand what number. I get that. I just,
And this right here is garnet.
I don't see those shapes a lot of the time.
Garnet, pretty easy. Okay, this is take 2 for symmetry. Isometric. 3 mutually perpendicular axes of equal length, such as pyrite. In the hexagonal system here, the minerals have they have 3 horizontal axes intersecting at 120 degrees. A 4th axis of different length is perpendicular to the plane of the other 3. An example is quartz and apatite. The orthorhombic system, minerals crystallizing in this system have 3 axes of different lengths, mutually perpendicular. So rectangular, so different lengths, but all orthonormal. monoclinic. Oh, an example of orthorhombic is topaz, apparently. In monoclinic, they have 3 unequal length axes, 2 of which are inclined to each other at an oblique angle, and the third perpendicular to the other 2. So we've got 2 oblique angles and 1 perpendicular angle here. That's monoclinic. In the tetragonal system, they have 2 equal length axes at right angles. A third axis of different length is perpendicular to the plane of the other 2. So we've got 2 equal length axes and one that's a little bit longer or shorter, but everything's at 90 degrees. In the triclinic system, finally, they have 3 unequal length axes, all intersecting at oblique angles. So basically, anything goes, as long as they're not the same length and they're not 90 degrees. So that's triclinic.